Okay, so we're now going to look at boundary walls, and we're just going to cover these points really quickly. Just quickly go through them now. Now, what is a boundary wall? We're going to talk about the heights, the foundations, the piers and the copings. Okay, so first of all, what was a boundary wall? If I was to quickly draw a semi-detached house, just to explain as quickly as I can. Right, so there's your house and your road or your highway. So I have to say that some new properties, you're not allowed to have a garden wall. My neighbour started to build a wall last summer, and I made one or two sort of like little suggestions to them on what they should be doing. When they went to plan, and they realised that they weren't allowed to have a wall anyway, so you'd always have to check with the planning department to make sure that you can put a wall up. But if there was a wall there anyway, most houses around here will have a wall on it. So we can see here that one definition of a boundary wall is it divides a property from the highway. And by the highway we just mean where you've got like roads, so just encloses the house into that area. And also where we have two properties, it divides, spell property, it divides two properties. Okay, so that's the two definitions for a boundary wall. Divides property from the highway and divides two properties as well. Okay, so we'll keep this drawn here just to go through the heights. Now, as I said, some newer buildings, they will have written in the deeds that you're not allowed to do a wall anyway, but places where you are allowed to do a wall, normally, again, there is no real control from building control on these things. It is a planning issue, but normally they're 900 to about 1 metre high on the front. When you come around the side and just put an extension on the back, just make sure it looks fairly realistic. Around the back you can go 1800 high, and even along the side, provided when you get to this side you don't block the view of the actual road coming down, so you'd always have to have like a viewing space for if there was a car sitting there. And so again, that's it. At the front, roughly 900 to 1 metre high, and the side and the back maximum is 1800 high. So we'll get rid of that, and we will now talk about foundations. And with there being no guidance or restriction on these, I came up with my own little formula, because I've done several garden walls in the past, or boundary walls, and I came up with this kind of like ratio, which kind of works, I think, really well. And again, you've always got to be aware of any foundation, what soil you're digging in. If it's clay, then you probably would be having to go a little bit deeper, but this is just a general rule. So if you had a garden wall that was going to be 1800 high above ground level, 1800, just 1.8 meters, this is the ground level. So the formula that I have is for every 4 courses above ground, you have to go 1 course below plus 150 millimeters of concrete minimum. So if we're 1800 high, that is going to be 24 courses. 24 courses of brickwork, So that means if you divide that by 4, you're going to get 6. So you have to have 6 courses, 1, 2, 3, 4, 5, 6, plus your 150 millimeters of concrete. That is the depth. Now, it doesn't mean you have to build 6 courses. Obviously, you could, as long as you go to that depth, which would be 1, 2, 3, that's 450, 55, 600. So you're going to be 600 mil below ground, but obviously to save time, you would just fill that with concrete and put a couple of courses before we get to the ground level. So that is the depth. 1800 high, you would be 600 below. Okay, so the reason for that as well is obviously because my neighbour was going to have a garden wall, but obviously they found out that they weren't allowed to. But the chap who was going to do it made a start, and I was a bit concerned because he was going to do his wall for them, and I think it was going to be around about 1500 high, and he only went down like barely a course. The concrete was more or less at that level. Now the problem with that is when you get wind pressure on that, there's nothing in the ground to stop that falling over, and obviously you have the potential of killing someone. So the depth is really, really important. So that is why I have my rule of for every 4 up, you're going to go 1 down plus your 150. So that is the rule that I go by. Every 4 courses above ground, you will go 1 below plus 150. So the bigger it is, the deeper you go. Okay, so the other thing that would obviously stop the wind pressure pushing that over is our next thing, piers, which go on the back. Now, I'll do a little plan view of a wall for this one. If we have a pier on the end, and we'll go as far as there. 1800 is the maximum distance you can go before you have to put a pier in. So this would be an end pier. This would be an attached pier. Spelled correctly, attached pier. Now, on for this one here, if you go to my YouTube, if you then go to playlists, if you then go to bonding lessons, and you should watch, off the top of my head, I think that's from bonding lesson 1 all the way through to probably 6, maybe 7, because after that I'll start dealing with cavity walls and positioning doorways and openings. But if you were to watch those ones, it talks all about the piers and things relative to that as well. Okay, so that's that. Last thing is copings, and after copings I have a few videos to show after this little lesson, which is going to reinforce what we're talking about here. So copings, there's 3 different types of coping you can have. One is a soldier course, which we'll talk about first. So, quick little sketch of a soldier course. Soldier course is generally what the wall is built out of. We'll say it's a pier there. So you will just have normal courses of brickwork underneath it there. Now what happens with this is the rain will hit this and run down. These are quite a porous brick, just being a normal face brick, and you'll find that the frost will start to blow all the tops of these. Also, this gets wet, the water runs off these ones as well, so you'll find that the courses below start to get really black and dark. Happens more when you use a denser brick on the top there, but this is like the cheapest way and the worst way to finish a wall off. The second way of the three is to use Cubans. Now Cubans, if they're concrete, they're a little bit of a problem. If they're stone, they tend to be more durable and they don't have the problems of concrete ones, but they are much more expensive. So a lot of people go for like concrete ones. I have to say, because of the problems, I haven't seen these on walls very recently, I have to say. I have seen stone ones going on, but anyway, I'll do a section drawing on this one. You can get saddleback Cubans, or you can get featherage, which I hardly ever see featherage anymore. Now the two little nicks I've put in there are called a throatin, and the throating is what stops the water running down the wall. So this will get rain on it, the rain will run round and the capillary action will take it along there, but it can't get past that, so it will just drip off, and the wall is there. The wall is there. So they do protect the wall, so they're good for that sense. But with a concrete one, I'm going to use a term here, the coefficient of linear expansion, which just means the rate at which materials expand and contract, are different. Concrete and brick are slightly different. So when I get hot and when I get cold, because one of them moves a little bit different to the other one, these often crack and they just come off the bed. So it's probably why I haven't seen these used for quite a while, because they do, like I said, just become dislodged and you're forever rebedding them. So you might as well go for the last one that we're now going to do. But again, in the videos you're going to see afterwards, you'll see what we're now going to do. People even get this one wrong. So it's an engineering brick. Very good for protecting the top of the wall. Engineering bricks plus crease and tile. That is the proper way. And in the video you'll see, I'll do a little sketch now, but you'll see in the video where people think engineering brick, best one to do, but they put it on without the crease and tile, and you'll see in the videos the problems that causes. So what we should have, I'll do a section again, you'll have the engineering brick, you'll have two courses of crease and tile, which are pretty much the same density as what the engineering brick is, and you'd have a cement fillet on there, so the water just runs off and drips off, and the wall is below there. Just a section or hatching for brickwork. So that will just like run off nicely. In the videos what you'll see is some people think engineering brick, that's what we want on top. So put an engineering brick straight on top of the facings. What happens there is the rain hits this is dense, the water runs down and saturates this. This is already getting rain on it anyway, so this gets like a double whammy of moisture on it. So you'll find, if we do the wall that way and the bed joints, this is our engineering brick on top, nice and dense. All these bricks start to go black, and then after a while the water gets in, the frost gets in, and all the faces start to blow off these. So again, you must have a crease and tile to get that water off the wall. Okay, so that's all our points covered. We'll now look at the videos and hopefully reinforce some of the stuff that we talked about. So here's a great example of a wall with just engineering bricks on top and no protection to the courses below. So the next way is to use a concrete or a stone coping, capons on the piers obviously, These are good, but the one thing I don't like about them is they have a different linear expansion to that of bricks, and they often do become dislodged. So here is a good example. I've just used a normal face brick for the top of your wall, like a soldier course. You just see the frost gets to it and totally blows it away. So on this one we can see engineering bricks just laid in stretcher bond, which obviously means they have to be solids, on 2 course of creason tiles, or as some people call it, tile creason. And you can see the brickwork below, none of it has been affected by water. You've got a bit of efflorescence on there, which is what you generally get anyway, but there's no mould or growth or anything on those courses just below the cabin that we have. And again, you can see engineering bricks used as a damp course at the bottom as well. So a good example there.